Okay, welcome back. We are going to work on the cake method, and we're going to do it with the greatest common factor, or GCF. Now, cake method can be used for prime factorization as well as least common multiple, but this one will simply go for greatest common factor, or the GCF. So your problems will look something like this. It will give you two numbers, and we'll do 12 and 18. So you will draw almost like an upside down division symbol on these, and you need to think of a prime number. So your little question mark on each one of these sections will be, what is the lowest prime number I can pull out of both numbers? And you ask yourself this question every time you do it. Okay, so what is the lowest prime number I can pull out of 12 and 18? The lowest prime number I can pull out will be 2. They're both even, so I can pull out a 2. Then I'm going to say 2 goes into 12 how many times? It goes into 12 6 times. 2 goes into 18 how many times? And that will be 9 times. Now, my next thing is, are these numbers prime? No. Okay. Do they have what lowest prime number can I pull out of both of them? Do they have a prime number in common? And in 6 and 9, your answer should be yes. They have a 3 in common. I can pull out a 3 in those. So 3 goes into 6 2 times, and 3 goes into 9 3 times. Now, is there a prime number that I can pull out of 2 and 3? Your answer is no. There is no other number other than 1 that 2 and 3 have in common. And so I've taught the students to just simply X that out for we're working on greatest common factor right now. So for greatest common factor, we're going to X that out. And this 2 and this 3 will be my GCF. So my GCF is equal to 2 times 3, which is 6. And that's how you solve the greatest common factor. Let's do another one. So the answer to this problem is 6. All right, let's do another one. Let's go with, let's do 36 and 48. 36 and 48. What is the lowest prime number I can pull out of both of those numbers? And that's easy. That's 2. So I then take that and I just do division. I said 36 division 2, and that gives me 18. And then I do 48 division 2, and that gives me 24. Now I have 18 and 24. What is the lowest prime number I can pull out of both of those? And again, it is 2. Okay, 2 goes into 18 9 times, and 2 goes into 24 12 times. Now, I'm on a roll, right? I'm going to go, oh, okay, what's the lowest prime number? And I stop, and I go 9 is not even, so 2 will not work. But 2 will go into 12, but not into 9. So that 2 is no longer an option. Now, I go to the next prime number in my prime numbers. And again, my prime numbers are 3, 5, 7, and we might go up a little higher to 11 in this class and 13, but we probably won't go much past that. Okay, so those are some of the prime numbers. So which one of those? 2? I guess I need to include 2 there. So we've done 2. 2 will not work. Now I see 3. Will 3 work? Yes, 3 will work. 3 goes into 9. How many times? 3. 3 goes into 12. How many times? 4. Now I look at 3 and 4. Will 2 go into 3 and 4? No, it'll go into 4, but not 3. Will 3 go into 3 and 4? Well, 3 will go into 3, but it won't go into 4 evenly. 5 won't work because it's too high. So I'm done. I will take my pencil or whatever I'm using, and I will gently cross that out. I still want to see those numbers down there. And then my answer will be, my GCF is 2 times 2 times 3. Or if you write it in exponential form, that would be 2 squared times 3, which would be what? What is 2 times 2? 4. 4 times 3 is 12. And your answer is 12. And that's how you do GCF with cake method.